Okay, welcome to this another lecture on basic surveying, and in this we are going to talk about the module 6. In module 6 we are going to cover triangulation and trilateration. These are also the methods of establishing control. What we will do today, we will begin with lecture number 1, because surveying is basically about the measurements. Two basic measurements there are angle and distance. For distances we have seen the methods which are like chain, tape, inward tape, or maybe the EDMI. Now for the angle measurement we can make use of a device like compass, but that is not very accurate. We have seen the reasons why it is so. So the more important device or more useful device here in this case is the theodolite. Now the modern version of the theodolite is the total station, which combines a theodolite angle measuring device and as well as the EDMI, the length measuring device. So total station is a complete device. So we saw about these also, that how to work with the theodolite, how to measure the angles, what are the procedures in order to measure the angles, what are the sources of errors, how to measure horizontal angle and the vertical angle, how to eliminate the errors. So all these we have seen so far. So our sixth module is triangulation and trilateration. In this we will begin with the very basic definition. We will see that what is triangulation and as well as why we need to do it. Then we will see some examples of the use of the triangulation, where exactly in field we can use it. Then what is the classical method of the triangulation? We need to measure one length or maybe sometimes 2 or 3 lengths in the case of the triangulation. So what are these methods of base measurement? Then we will see the different orders of the triangulation figures. How do we select the figure? What are the criteria for that? Then finally we will look into the great trigonometrical survey of India. So here we begin with this module. So let's start with what is triangulation, and I am writing here triangulation, and in order to save my time I will use this as the symbol for the triangulation. Number 1, we will see what it is. What is the triangulation? And as well as we will try to see, because once I am trying to answer this what, we will also answer how we do it. So basically triangulation is a network of triangles which we are trying to do in order to establish a control network. I will come to these terms later on. What is the control network? Though we have seen that before also. So the moment I say a network of triangles, the meaning is we are trying to cover our ground by a network made by the triangles. Now here in this case, the ground, if I draw the ground here, let's say that was the terrain. Over there we have a road, some houses, some trees, some more roads. Now we want to make a map of this blue area. The blue area is the ground, is the terrain. In order to make a map of this blue area, we do the triangulation. So what is the triangulation? We are covering this entire area by means of these triangles which are shown in black, and the red ones are the triangulation stations. Well, why the triangulation is important, why it is significant? If you remember, in those days when the EDMIs were not available, now also even if the EDMI is available, we have to measure so many distances in order to make the triangles by measuring the lengths. So at that time when the length measurement is costly, because EDMI is a costly instrument, what we would like to do, we would like to make use of our theodolite, which can give us very cheaply the theta, the angle measurement. So in this figure, if we have an instrument which can measure the angles, the theodolite, very cheaply and without much cost, and we want to have some method of measuring only one length here. What I mean, now in this I measure one length very accurately using some method. This method could be the chain, this method could be the inward or whatever. So this length which we are measuring here is called the base length. I write it here, or base measurement. So we are measuring, we are putting all our efforts in order to measure this base length accurately. Then later on, because we know we have a theodolite with us, using this theodolite we measure all the angles. So all these internal angles of the triangulation figure are measured. So what we did, we measured the length only once for only one line, but we are measuring all other angles. Now you know that it is very easy to measure the angles, because you have to be physically in one place. You have to just bisect the targets. So standing at this point A, you can bisect a target at B and a target at C, and the angle is measured. But to measure the length, if the EDMI is not available, what you have to do? You have to stretch your tape or chain along this line AC. Well, it may be undulating terrain. The length measurement is subjected to more errors than the errors in the angular measurement. So what we are in a situation like where we can carry out the angular measurements in a better way, more accurately, without much problems, but not the length measurements. Well, even if that is the case, just by knowing this single line and all these angles measured, as you can guess now, we can determine the coordinates of all these points. Having known, for example, let us say I know the coordinate of point A. The coordinate of point A is known. So by knowing this length and all these angles, I can determine the coordinates of B, C, D and all other points. So what we have done, by measuring these number of angles and only one length, we are able to generate a network of control points for which we know the coordinates over the ground. So this is what is the triangulation. Triangulation, as we can see here now, is a network of triangles which is used in order to cover that entire country. So in a way we can also say it is giving us a skeleton. A skeleton of the area. We are producing a skeleton of the area, and we can use that skeleton later on for our work. So we have understood right now what is the triangulation, a network of triangles. We also know now that why we went for it, because it was easier to do it with the help of the angular instrument and only one length was to be measured. Okay, now we'll see, because we are saying the triangulation is we measure one length, which is the base length, and then later on we measure the angles. For example, in this figure, all these angles are measured, and as well as the length is measured, the base length, only one length. Having done this, we will have the coordinates of all these points, so we are able to establish a network, a skeleton of the area. Now the question is, how do we measure, number one, the angles? We know the method. We can use theodolite, and we also know how to measure the angles with the theodolite. We can measure the angles in horizontal plane as well as in vertical, because starting from point A to point B and C, I can measure the horizontal angle, that is B, A and C, as well as the vertical angle at A to B, because we can establish now the vertical control also with the help of these vertical angles. Now the other thing is how to measure this length. If the EDMI is available, well, the length measurement will be easier. As we have seen, it's a very fast method. But in case if the EDMI is not available, so it's a costly instrument, not always you may have the EDMI available with you. So in that case, what to do in order to measure a length AB accurately? Well, if this length AB is small, for example, only 100 meter or less than that, 50 meter, In this case, you are doing the triangulation in order to cover a very small area. Let us say your civil engineering department or wherever your building is, just the nearby area, the neighborhood of that area, you just want to do a triangulation in that area. So in that case, your length of the sides or the base length will be small. So your length could be only 100 meter or 50 meter or so. In that case, you can directly measure it using the tape or chain by spreading the chain or tape on a flat stretch of the ground and also applying the corrections. But many times your base length may be of order of 5 kilometer. This is what may happen, 1 kilometer, 2 kilometers. You are doing the triangulation in a hilly terrain in order to cover an area of 30 kilometer by 30 kilometer. So your base lengths are of 2 kilometer length. How to measure that base length if you don't have the EDMI with you? Now in that case, we go for a method. In the simple cases, when we want to measure a small base length, because as you understand now, in the case of the triangulation, the accuracy of these coordinates, of all these coordinates, the accuracy of all these will depend upon the accuracy by which we have measured the base length. If your base length is wrong, all these coordinates will be wrong. So we have to exercise all our precautions, make the best effort in order to measure the base length accurately. So in the case of the simple cases, we will be using the invar tape. You know the use of invar tape, why we use the invar, and in catenary. Now you know what is the meaning of that. We discuss about that. We will be using the invar tape, in catenary, and we will be applying all the corrections for all the kinds of the errors. Then only we can determine the horizontal distance between these 2 points. Invar, because we are using it because of its thermal expansion properties. It doesn't expand much with the change in the temperature. It will maintain its length. And then we are applying the corrections for this catenary and all the other corrections. So we can measure a small length correctly using this approach. So this length could be of order of 100 meter to 500 meter, depending what kind of ground you have, how much efforts you are putting into it. Well, what if your base length is of order of, let's say, 2 kilometers or 5 kilometers? What in that case? See, think of a hilly terrain. Somewhere you want to make a map of the hilly terrain. You want to do the triangulation in a hilly terrain where your base length is of 2 kilometer length. Now you want to measure that. Hilly terrain means a terrain like this, and these differences in heights are of order of, this point may have an reduced level. The height of this point may be, we can say, 100 meter from mean sea level, while this could be 1000 meter. In a distance of only 1000 meter, there could be a difference like this. So our terrain is very much hilly. Your one station is here and the other station is here. You want to measure this as the base length, which is of order of, as you can see, this is 1000 meters, so let's say 1.5 kilometer. You want to measure this horizontal distance. You cannot spread your tape or chain or anything here. That's not possible. You would not like to carry out the measurement this way. So what should we do? The method which we can suggest is, we say base extension. Now what is this base extension? Even in this area, which is highly undulating, we will try to find a site which is flat, which is small, that may be very small. For example, let's say it's here. I'm showing it by red. A site which is here, which is flat and which is small. Now what we would like to do, we would like to measure a base over here very accurately, a very small base, and then we would try to connect this base to this one, say point here and point here, by some means of triangles, so that having known this length, we can compute this length. How it is possible? Well, this is possible if, for example, let us say my small waist length which I was measuring is this, and that is only 100 meter or even less than that. I could find a stretch of the ground there which is flat, and I could measure a very small base length accurately. Now I want to connect it finally to this big base. The actual base for my triangulation is A and B, which we are not able to measure directly, as we know because of the problems in the terrain. It's a huge length, it's 1.5 kilometer of that kind of order. So what to do? Well, what we will do, we will start with this small base that we have measured, and we will try to extend it. Let us say I establish just 2 points here, point A dash and point B dash. Then I measure these angles. All these angles are being measured by theodolite. Theodolite can measure the angles, that's not a problem. Once I have measured all these internal angles, I know the length of this black line. We had measured that, it was possible for us. I can compute the length of line A dash B dash. So the length of the line A dash B dash is computed. Then further I establish 2 more points. Let us say it is A double dash and B double dash, and then I join this A dash B dash to A double dash B double dash, and again using the theodolite I measure the angles here. So measuring these angles is not a problem because theodolite can measure any angle anywhere. So again what I am doing is starting from this A dash B dash, and all the internal angles which are measured by the theodolite I can compute A double dash B double dash. So I know the length now A double dash B double dash. Similarly, I will try to connect now this A double dash B double dash to AB. How we can do it? My purpose is to determine this length. So what I am doing, I know this length A double dash B dash, as well as I measure all these internal angles here. I can occupy AB and we can measure these angles. So once we are measuring these angles using the figure here, using this figure I can determine now, starting from here and the internal angles, I can compute the length of AB. So from A double dash B double dash we have the length AB. So what we saw here, and one more thing, please keep in mind, the moment I say standing at this point B, I am bisecting a point here B dash and a point A dash. What we are doing, we have a ranging rod or we have a something called signal standing there, and we are bisecting the signal and we are able to measure these angles. So what we have seen now, we have seen that we can start from a very small base length which we can measure correctly, and we can extend it further into the base length which is desirable, because the desirable length in this case was AB, which we are not able to measure. But now, having done all this process, all the computations, we are able to establish the length of AB. So what we have done, we have measured our base length. Next we will go that, because we have not yet answered that why triangulation in full. By this time we know what is triangulation, how we do it also a little bit, and also the length measurement, angle measurement in that, but we do not know right now in full that why we go for triangulation. The basic thing for going for the triangulation is, I can say, establishing the control network. Now the moment I say control is of 2 types. One is horizontal and the other one is a vertical control. Now what these are, we have also discussed these before, but I would like to revisit these things in order to understand the triangulation. What is the meaning of this? if there is an area, I'm going to draw a map of some area. Let's say this is the area. Now over here we have some roads. Okay, I'm just showing a smaller area which you can relate easily with. The area could be very large also. We also have some houses here. We have several trees and other things here, just like any area. Now what we want to do, we want to make a map of this area, and this area is of size, let's say this is 3 kilometer wide in length and 1.5 kilometer wide. That's the size of the area. So we have an area, this big area, and we want to make a map of this area. How should we proceed? We cannot do it by compass. We can do it by compass, but compass is not accurate. We have seen one method of traversing. In the case of the traversing, we are measuring all the lengths. The problem with the traversing is that you measure the angles as well as you have to measure all the lengths. And measuring length, it takes time. So we don't want to do it by that method also. So we want to do it by a method in which we are measuring a number of angles but only few lengths. How to proceed with that? Well, what we can do, we can begin with, I establish a point here, I establish another point, and I join, let's say, it with this, then a point here, and then a point here, let us say. Now all these points are intervisible. This is how we have selected it. So what we have done, we are making a set of triangles here. Now in this set of triangles, one length we want to measure accurately. So let us say this is the length which I measure accurately by spreading my chain or tape or by base extension method. As well as I am measuring all these angles now using the theodolite. So because measuring angle is not a problem, so all these angles are also measured. Once this job is done, I can come back to the laboratory, and in my laboratory, using my field observations, using the length of all these lines, length of one line, which is the base length, and as well as all the angles, what I can do, I can start plotting it. One more thing, let me give you one more term here. That term is called Laplace station. Laplace station. In triangulation, we define a term Laplace station. The meaning is a station where we are taking the bearing of one line. For example, in this network itself, if I am taking the bearing of line here, so the meaning of bearing is, if I take the bearing here from the north direction, I am measuring this angle. That's the bearing. So for one line, we take the bearing. Now why we are taking the bearing? Again, it will become clear in a moment. Similarly, because as you understand now, starting from the known line, our known line here is this, and as well as all the measured angles, we are finding the length of all these lines. In order to exercise a check, because in our very first lecture, we were talking about the significance of check in surveying. So in order to exercise a check, what we can do, I can also measure one more length here in the field. Because what we are doing, we are starting from here, which is measured base length, all the angles known, we are computing this length. Now this length which is being computed can be also measured in the field. And this measurement or the measured length and the computed length, they should agree. If they are not, our survey has some problem. So this kind of length which we are measuring later on are called the check lengths or check base. If I write it here, it is we are using it for check, it's check base or the check length. So we have defined two terms, the Laplace station and the check base here. Well, in order to plot this traverse, how we will begin? We will start from our very first point, the point which was on the top. I know the direction of the north here. So that's the direction of the north here. I know the bearing of my one line, and by computation I know the length of the line. So I plot this. Then I know the internal angles. I plot the second one, I plot the third one, fourth one, and so on. So I can plot on my drawing sheet the triangulation network which was in the previous case has been plotted now. Now it may not be exactly the same as in the previous case, but well, here in my plotting, here in your screen, otherwise it will be same. In actual case it will be same. So this is the drawing sheet here. In the drawing sheet this network has been plotted now. So this is the network which we say the control. Control means that area has been brought into or onto the drawing sheet now by means of these control points. So these control points capture that area, or these control points capture the skeleton of the area. Now what we can do in order to make the map here, I can go now in a small part of this area. For example, let us say here I start measuring the offsets, or maybe even by angle measurements. I measure these two angles, I fix this point. So what I am doing here now, once I have got the offsets and other things, I can start plotting the things here also. So I can start plotting my things, as in the case of the field. Whatever was the field, I can make the plot here, because now my control is fixed. I am doing the plotting now with the help of the control. So if you are committing some error, for example in this part, that is not going to affect this part in plotting the details. So this concept we have seen before also, and this concept we know, working from whole to part. What we have done, the moment we capture this network of the control points or the skeleton of the area, we are establishing the whole, and now we are working to fill up the details in the parts. So this is the concept of the control. We are making use of triangulation in order to establish this control, which we are making later on in order to plot the details. Now another way in which this triangulation or this control can be used, and right now the control which we are seeing is only in horizontal, but the control is in vertical also, because I know not only x, y, but the z coordinate also of this point. If I have, for example, in my triangulation figure, I know, let us say, the RL of this point. RL stands for reduced level. We will talk about that later. That is the height of this point from the mean sea level. I know the RL of this point. Once I have measured the vertical angles and the horizontal angles, I know this length. The length here I will show again. I know this length, it is computed, as well as I know the vertical angle here. So I can compute the RL of this point also. So basically what we are doing, we are computing the x, y, z of all the points. So it's a full control. Y and z is a full control for all the points. The other use of triangulation could be in setting out operations, or the control network, the use of control network in setting out operations. Now here in this case I will give you one example. Let us say we have a railway line coming here, and now over here we have in this area a hill. So right now I am showing the hill by these contours. Okay, we will talk about these contours later on. Now a decision is taken that this railway line, instead of going from outside this way, should pass through a tunnel in this hill, and it will exit here. So the decision has been taken now about the point of entry and about the point of exit, and now in between there is the hill. So what we are looking at? We are looking at a situation like this way. The railway line is entering here and it is coming out here, and in between there is a slope. So the railway line has to follow this formation in order to come out of that place. Now this length is very big. Let's say it is 4 kilometer. In order to excavate, the excavation for this tunnel will begin from here and as well as will begin from here, and at the same time it may also begin from some intermediate points through the shafts. And all these excavations starting from here, from the shaft and as well as from this end, all will become simultaneously. Now the challenge for the surveyor is that these people, he has to give directions to this party in order to move in a particular direction, maintain a particular gradient. Similarly for this party also and as well as this party also, how much to dig in the shaft so that you are at the formation level of the tunnel or at the center line of the tunnel. So in doing this, we make use of the control which is already established, and after reaching here, then this gentleman will start digging in either direction, and all these parties should meet, the center lines should meet. So this is really the challenge. Now how the surveying or the triangulation is going to help in this, or how the control network is going to help in this. So if you look at the previous figure was like this. In the previous figure, we have, for example, let us say establish a triangulation network. These points are intervisible, and in order to map this area, a triangulation was done. So this is a network of triangles using which the area has been mapped. So what we do, we bring this map to a laboratory. So the map in the laboratory will again look like, of course this is in a drawing sheet. That's the map of the control point. As well as in this map, because we have done the mapping, we have the contours. And now the decision is taken about the tunnel. Well, the tunnel will pass along this center line. Now if this decision is taken, this is being taken on the drawing table, on your drawing board. You are working in the office and you are taking this decision. Now the next job will be, because that's the entry point, that's the exit point, next job is to locate the shaft. Okay, the first shaft will be here, the second shaft will be here. So that is the decision again being taken in the office. Now once in the field, there in the field, you have to locate now where the shaft is, where the center line is, how much deep you should go in the shaft here. So in order to locate this shaft here, this shaft for example, what we will do, we will make use of the control network. Let us say just for this case, this shaft makes certain angles from the line here, which is the control line, a line made by the control network. So if I know this angle, I can now with some more measurements locate this point in the field also. Starting from here, I had measured the angle, as well as I measure the angle and I locate the point. So this is the point where my first shaft should be. So what you are doing, you are setting out a point. You are making use of the control network to set out this point. Similarly, you also know the RLs. You know the RL of this point, the reduced level. You know the RL of this point, the reduced level. You know the formation level. The formation level is this. So there in the laboratory itself, you are determining the RL of this point. You know the formation level. So you know the RL of the formation level everywhere. So at this point, if you come vertically down, how much down should you come from this RL so that you reach the center line of the tunnel. So all these kind of computations can be done if you have a network for which all x, y, z are known to us everywhere. So we are making use of the control network, we are making use of the triangulation for this purpose. Well, having seen all this, now we will talk about more about the triangulation, because we know now that what is triangulation, how we do it, a little bit of it, why we do it, what is the use of it. Now, the very first thing we will start with is triangulation figures. So what are the triangulation figures? Generally, because so far I was showing you only one chain of triangles. What are the others? The very first figure of triangulation is a single chain of triangles. Well, we know one length here, we know all these angles. So having known all these, the coordinates of all triangulation stations can be computed and the control network can be established. Now this kind of chain of single triangles is not a very good figure. Why it is not a good figure? Because we have only one root for computation. Now what is this root of computation and why it is important? Root for computation. The meaning of this is, starting from A, B, if you want to find the length x, y, we have only one way to reach there. We will be making use of the sine rule because we know the angles here, so we can compute the x, y. So we have only one way, only one route. We will see in some other figures that we can go through multiple routes. So we will have a check on our computations also. Now this kind of figure, the single chain of triangles, as you can think, in which case it will be suitable. Well, if we have, let us say, a river, and this river flows like this, and your job is to plot or to map the outline of the river. So this single chain of triangles will be a very good figure. You just establish this and then start plotting the offsets. You will be able to plot the boundary of the river. So this figure is good in this kind of scenario, but not always. The other figure is, the second which we can say, braised quadrilateral. Now what it is, you know the quadrilateral is a chain of quadrilaterals which are braised. The meaning is a figure like this, just a figure like this. Here one length is known to you and all these internal angles are measured. Similarly here, by knowing all these internal angles, you can do the computation and you can find the length x, y or any other length here which are unknowns. So this kind of figure gives you a flexibility of doing the computation from multiple routes. Now how it is so? If you look at this, we have line AB, which is the base length which is measured, and you want to determine the line C and D. In order to compute the length of line CD, what we can do, we can start, number one route I am drawing by red, we can start from first this last triangle, starting from AB, I compute, let us say, AC. Then from AC, I compute CD. Or starting from AB, I compute BD. Now using the triangle here, ABD triangle, and then from BD I compute DC. So what we are doing, we are computing the same length DC or CD through various routes. In this figure, as you will see, there are 4 possible routes. So we have a check on our computations, as well as we will see later on that we can choose a route which is the best for the computation. So this figure has got this flexibility. This figure is said to be the best figure. Now where we can make use of this figure? We can make use of this figure in order to create, as in the case of our river also, for example, simple river, and we can create a chain of the braised quadrilaterals, or maybe in some other case, let's say for a hilly terrain, I am drawing the contours just to show the hills. It's a hilly terrain and some point here. We want to map this. So what I can do, I would prefer to establish a braised quadrilateral here in between these hilltops, and then somehow by a base extension method I will measure this one, all internal angles. Now I have got the control established for this area, and using this control, these triangulation stations, later on I can make map of this entire area. Everywhere here I can make the map. So this braised quadrilateral is very useful figure. The another figure which we make use of is 3 centered figure. The centered figure is somewhat similar to the braised quadrilateral, but has got more work to be done. Again, now the difference in this case is we occupy the point here also. We measure all these angles as well as these. Now this figure can also be used in a hilly terrain. These all A, B, C, D, E, F are the hilltops. We have to also go to this hilltop G and to measure these angles. While in the case of the braised quadrilateral, we were not occupying the center point. We are just measuring these angles. We are not occupying this point. There is no point as such here. But here in this case, we have to occupy this G in order to measure these angles. So this kind of figure is the centered figure. Now the question arises that how to select a figure. Basically, for any problem that you are thinking, you have to make a map of the river boundary. You have to make a map of a hilly terrain, 30 km by 30 km. You have to map the reservoir of a dam, which is around 42 square kilometer in the extent. So depending your problem, you decide that what kind of figure will be suitable for you. But some of the things, some points which we should keep in mind. Number one, a figure could be, as we have seen, only single chain of triangles, single chain of quadrilaterals, or maybe only one quadrilateral. If your area is 10 km by 10 km, you are going to make a map at very small scale, 1:50,000, 100,000. In that case, only one quadrilateral can do. Or you may also go for, in some cases, a chain of quadrilaterals or a chain of centered figure. Many times all these figures may be combined. Here I am giving you an example of the combined figure. We started with a chain of triangles, and here is a figure which is combined figure. Combined means we started with first one triangle, second triangle, the base length is known here, it is measured for this. Then we have a centered figure here. As you can see, figure which I am drawing now in red is a centered figure. All these internal angles are also known. In addition, there is a base quadrilateral. So it's a combination of all the figures depending the field condition, depending whether you could locate your stations or not. Over here, the requirement of the field was only 3 stations, so you went for a triangulation, just a simple triangle. But here you found that you can find 4 stations and the requirement was like that, so you went for a base quadrilateral. So your figure could be anything. Now, while we are selecting the figure, some of the points which we should keep in mind: number 1, the figure should be such that we can do computation from or through 2 roots. Now, what is the meaning of that? We know already the computation roots. In single chain of triangles, only 1 root is possible. We should have minimum 2 roots for computation, so that we can have a check. Number 2, possibly we should have well conditioned roots. Now, what are the well conditioned roots? What is the meaning of this? We will look into it in more detail in a moment, but let us say I explain it graphically. You have a line A, B, you know the coordinate of A as well as coordinate of B. You are going to fix a third point C, and the third point C, if you fix, let us say, by a very large angle between these over here. In one case you are fixing it by a very small angle. That's a very small angle for C, and as well as this C. Let's say I say it's C dash, C triple dash, and a point here in between you are fixing where the angle is nearly 90, which I say C double dash. Now, because what we are doing, we know point A, we know point B, we know this angle, we know this angle. I am just taking the arcs. I am just cutting these 2 arcs here, or maybe we know the length. I know length AC triple dash, BC triple dash. I am taking these 2 arcs and cutting this and trying to plot the point C triple dash. Now, how these arcs will look like? These arcs, if the angle is very large, the arcs will cut somewhat like this, or if the angle is very small, the arcs will cut somewhat like this. If the angle is 90 degree, the arcs will cut 1, and for 90 degree it should be like that. Let me make it a little bit thick so that it is same as others. Now, what are the differences in these? Over here in this case, see, your point of intersection is somewhere within this area. Where it is, that is the uncertainty. So, if the angle was very large, the uncertainty in locating this point C triple dash is large. It could be anywhere in between. Similarly, over here also the uncertainty is large if the angle is very small. You can do it graphically. But if the arcs they intersect at 90 degree, the uncertainty is limited to only this particular thing. So, uncertainty in locating point C double dash is least. So, what we are doing here is starting from 2 known points, we are trying to establish the third point, and in establishing the third point we have some uncertainty, and it depends upon what kind of angles we are choosing, where this point is. If the point C double dash is such that the angle of intersection here is 90 degree, the uncertainty in establishing C double dash is least. The same thing we do in the triangulation. Though we do the computation from a known length, the base length, from the known angles, we measure these angles, we are trying to fix this point C double dash from this A and B. Now, depending how much uncertainty is there, it will depend upon the kinds of the angles which are there in the figure. Well, we want this angle to be 90, which is not always possible. So ideally we say if the angle of intersection here, or rather all the angles of triangle are within 30 degree and 120 degree. All these three angles are not beyond this value. Our triangle is well conditioned. We will explain this also later on in the computation part, but right now we have been able to understand graphically that if in my triangle the angles are within 30 and 120, they are not either too large or too small. In that case, the computation of unknown points is more accurate. So these are the well conditioned triangles. Now the meaning of well conditioned root, because we started this discussion from here, that we should have well conditioned roots. The meaning is in our triangulation network which we are going to finally make, which we are going to finally choose, our triangles should be well conditioned so that our computations are accurate. So that's the second point in order to choose the triangulation network. Then the next point, third, the triangulation network which we choose should be, or the triangulation figure that we choose should be such that it should cover the entire area. That is the purpose. We want to establish a control network for the area. So our control points or the triangulation stations should be such that, our figure should be such that it covers the entire area, because we are going to make use of this triangulation network later on. We have seen it. We make use of this in order to make the map whole to part. We make use of this in order to set out. We saw the example of the tunnel. So our network should be such that it is covering, it is governing the entire area, or the skeleton of entire area is within the network. Okay, now we will talk about the framework of triangulation for a country, because in any country we have a reference system, and that reference system is established through a network of triangles. For the entire country there should be one network of triangles which gives you the coordinate in that national reference everywhere. Now what is this framework which is covering the entire country? The framework of a country could be of two types generally. One is the gridiron, and here we are seeing the gridiron system for India. See, this figure is very interesting figure, and it explains that what the gridiron system for India looks like. Here each line here, for example like this is a chain of triangles, or for example it is something like this, made of triangles, something like this. A chain of triangles is starting from here going all the way to the north. Similarly some more chains of the triangles, and as well as some chains which are going in this direction. So this kind of framework, which is generally useful or done for a large country, is called the gridiron system, as it appears as if there is a grid, and by this grid the control points are established everywhere throughout the country. This is also an example of the great trigonometrical survey for India, a survey which started some 200 years back, and starting from somewhere in Chennai, Madras, this network was established throughout the country, and later on more triangulation chains were established and the network was completed. So what we have a feeling, what we understand by this, we have a network of control points everywhere in the country. All of them are referring to the same reference system. So we can measure the distance having known the coordinates of this station and this station. I can know the distance between these 2 points because everything is in one reference. So this kind of system is the gridiron system. Another picture for the gridiron system. Don't confuse with these red lines, but just the background in the figure. And you can see this, I have taken it from this source. The another system for any country is centered system. The centered system is done if the country is small. India is a large country. We cannot cover entire country everywhere by the triangles. But for a smaller country like United Kingdom, it is possible that a chain of network of triangles is covering the entire country. As you can see here, this is the boundary of the country here. I can show the boundary like this. Okay. So this is the boundary. While everywhere in the country there is the triangulation network. So this kind of figure is called the centered figure. Now we will look into order of triangulation. The order of triangulation means, for example, let's say for the United Kingdom, this is the very first triangulation network here which we are seeing. If we want to work in between this area, so this area is a quadrilateral here. Now this quadrilateral, the sides are very big, they are of order of 30 kilometer, and your area of interest may be only here. So what you would do, you would pick up the control from this main network and you will try to extend it in this area. So you will try to establish some more network of triangles here, which are taking the control from the first network which is available to us and then extending in this area. So in this way, we see the very first network to be the primary triangulation. Then within that, we can have network of lesser accuracy, which is the secondary triangulation, and further within that we can go for the tertiary. So the details of these are listed here. Of course, there are many more details which you can find in any standard textbook. For the first order, which are the most accurate, which are used to establish the the shape and size of the earth in that part of the world, that part of the country very accurately. Generally, these are very, very large triangles of the order of 8 to 12 kilometer base length. The sides may be 16 to 150 kilometers, and these have to be very accurate. Just one measure of accuracy is average triangle closure should not be more than 1 second. So we have these specifications for this first order of primary triangulation, which is very accurate. Then within that network, we can have the secondary one, which is slightly less accurate, then tertiary one, again further less accurate. Again we are going with that same concept, the working whole two part. First, this first order, which is very accurate, second order slightly less accurate, third order, and then within that third order also, for your own application, you can go for one more set of triangulation, which is even inferior than that. So in any country, as we can see here, we can have these primary, secondary, tertiary, and if you go to the field, you can locate those stations. In India, for example, if you walk here in this area, you can locate those GTS stations, the Great Trigonometrical Survey stations. You can find them, and you can determine their, you can get their coordinates also from Survey of India in order to relate your survey to the GTS. So what we have seen today, we have seen the triangulation, why we do it, how we do it, what are the triangulation figures, and how we decide that okay, this triangulation figure should be used. So we have seen these concepts. Then we saw about a country, whether the pattern for a country should be gridiron or should be centered figure depending upon the size of the country. So this gives us a background in order to go for our next lecture. Thank you.